In this presentation, I am going to speak how to analyze the 3-span continuous beam when one end is fixed and the other end is overhanging. Already you know these are the steps, that is application of momentation method to continuous beam. These are the steps. So first you have to find out the fixed end moment and distribution factor, then balancing moment and carryover, then repeat the balancing and carryover. These are the process you have to remember. Already I explained in previous PPT. These are the steps you have to remember. So coming to this problem, so this is 3-span continuous beam. This is 3-span continuous beam. Determine the support moments for the continuous beam as shown in figure. EI is same throughout. So this is the 3-span continuous beam. So here you see this is 1, 2, 3, 4. These are the support and this is 5. So this portion is overhanging and this side is fixed. This end is fixed and this side is overhanging. And on span 1, 2 there is having 2 concentrated load at a distance 2 meters from the support 1 and from support 2. So this length of this span 1, 2 is given 6 meters, and here the load is present 2 meters from 1 and 2 meters from support 2. And this is span 2, 3, the length is given 4 meters, and this is span 3, 4, the length is given 4 meters, and the UDL is present 40 kilonewton by meter on the span 3, 4. And on span 2, 3 there is no loading. And here the concentrated load for this overhanging portion 1.5, for this overhanging portion 1.5, there is having one concentrated load 50 kilonewton at the end 5. And the length of this overhanging portion is given 3 meters. So this is all about the continuous beam, 3-span continuous beam. And here this is the moment of inertia is given for span 1, 2 is I, and for span 2, 3 given I, and for span 3, 4 given I. So this is the data given for 3-span continuous beam. So what is your first step? So first step that you have to find out the fixed end moments. So first you take, this is overhanging portion. So you have to treat this as a cantilever and you have to find out what is the moment here. M15. M15, this is load and this is the length. 50 into, this is 50 and the length is 3. So what is the moment? M15 plus 50 into 3, this is plus 150 kilonewton meter. Then find out what is the fixed end moment for 1, 2 and 2, 1. MF1, 2 and MF2, 1. So by considering this as a eccentrical loading, you have to take this as a eccentrical loading and you have to find out what is the MF1, 2 and MF2, 1. And also you have to consider this as a eccentrical loading. You have to find out MF12 and MF21. So first you find out MF12. Take this is concentrated load, eccentrical loading. Take this is eccentrical loading. This side is 2 meters and this side is 4 meters. W AB square by L square. W is given 80. 80 into 2 into 4 square by 6 square. And for this load, 80 into 4 into 2 square by 6 square. So this is MF12 is equal to minus 106.66 kilonewton meter. Then find out MF21. So first you take this load, W A square B by L square, and for this one W A square B by L square. So MF1 is equal to plus 106.66 kilonewton meter. Then for span 2, 3, you have to find out MF2, 3 and MF3, 2. But here there is no loading. So what is the moment? Fixed end moment MF2, 3, 0. And MF3, 2 is also 0. MF2, 3 and MF3, 2, 0. Then for span 3, 4, what is the fixed end moment? MF3, 4 and MF4, 3. Here this is given the UDL. So for UDL, what is the moment? Minus W L square by 12. You know, minus 40 into 4 square by 12. This is minus 53.33 kilonewton meter. And MF43 is equal to plus 40 into 4 square by 12. This is plus 53.33 kilonewton meter. Then what is the relative stiffness of the members? Here you see this is the overhanging portion. If the end is overhanging or simply supported, then for this corresponding span, you you have to find out the relative stiffness 3/4 into I by L, because here this is overhanging. So you have to find out what is the relative stiffness of this member, this span 1, 2. So here you have to take 3/4 into I by L, 3/4 into I by 6, 3/4 into I by 6. K12, K21 is equal to 3/4 into I by 6. And for other span 2, 3 and 3, 4, you take simply I by L, I by 4. And for this span, for span 2, 3, I by 4. And for span 3, 4, I by 4. K23 is equal to K32 is equal to I by 4. Similarly, K34 is equal to K43 is equal to I by 4. So these are the relative stiffness of the members. Then find out the relative stiffness of the joints. So here you see how many joints. So this is one joint. You have to find out K3, and you have to find out also K2. For overhanging, you have to take the distribution factor. Here is your 1. So first you find out the relative stiffness of the joint. Joint is your K21. K2 is equal to K21 plus K23. Already you know K21 and K23. K21 is equal to I by 8 and K23 is equal to I by 4. I by 8 plus I by 4 is equal to 3I by 8. Then find out K3. K3 is equal to K32 plus K34. This is also I by 4 plus I by 4 is equal to I by 2. Then find out the distribution factor. So here you take at joint 1, that is distribution factor is equal to R12 is equal to 1. Then find out R21. Then find out the distribution factor R21. R21 is equal to K21 divided by K2. Then find out R23. R23 is equal to K23 divided by K2. You know that how to find out the distribution factor. That is the relative stiffness of the members divided by the relative stiffness of the joint. So for 2-1, R21, K21 by K2, and R23, K23 by K2, then R32, K32 by K3, then R34, K34 by K3. And for R43, this is piston, so you have to take the distribution factor is equal to 0. So these are the distribution factor R1 to 1, then R21, K21 divided by K2, I by 8 by 3I by 8. You know everything. K21, K2. This is K2 and this is K21. You have to put here. So R21 is equal to 1 by 3. Then R23 is equal to K23 by K2, I by 4 by 3I by 8, 2 by 3. Then R32 is equal to K32 by K3, I by 4 by I by 2 is equal to 1 by 2. Then R34 is equal to K34 by K3. This is equal to I by 4 divided by I by 2 is equal to 1 by 2. Then R43 is equal to 0. This is due to piston. So these are the distribution factors you have to find out. Then you have to go for the distribution and carry over the moments. So first you have to draw the continuous beam. Then at the corresponding joint or support, you have to draw the vertical lines. You have to draw the vertical line. Here 1, 2, 3, 4. Here draw one line. At 2 draw one line. At 3 support draw one line. And at 4 support draw one line. Then you know what is the distribution factor. So first you have to put the distribution factor. You have to make a block for 1, 2, for 2, 1, for 2, 3, for 3, 2, and for 3, 4, and for 4, 3. You have to put R1, 2 here in corresponding column and R21 here in corresponding column. Then R2, 3 here, then R3, 2 here, then R3, 4 here, then R4, 3 here. So in corresponding column, you have to put the distribution factor value in a rectangular box. Then write the piston moments. You know already one M15 150 and MF12. You know minus 106.66. You know if the end is overhanging. So what is the moment here this side, and also you will get the same moment this side in opposite side, so that the moment will be balanced. You know here 150. So you have to find out also this side minus 150. Then the moment will be balanced. So first you write the moment. This is 150, and here you got minus 106.66, and here you got MF21 got plus 106.66, and MF23 you got 0, and MF32 got 0, and MF34 you got minus 53.33, and MF43 you got plus 53.33. So what you have to do here, so when the end is overhanging, so for that corresponding end, first you start the balancing and carry over. So here you start from the joint one, because joint one is your overhanging portion, and you know for this overhanging portion what is the moment this side. So also this side also you will get the same moment, then that will be balanced. So here you know this is balancing of joint one, then you take the carryover of this moment to the other end. So what you have to do here? So first you have to start from the joint one. So what is the net moment or unbalanced moment here? Here you see this is 150 and this side is your minus 106.66. So what is the unbalanced moment here? 150 minus 106.66. So this moment you got here positive unbalanced moment, and this moment you have to multiply with 1 and you have to put this side. Here you got the unbalanced moment is your plus 43.34. 150 minus 106.66. So here this moment the unbalanced moment is your plus 43.34, and this moment you have to multiply with this one and you have to put in opposite sign here, so that the joint is your balanced. Minus 43.34. Here you see this is 150, and here this side also you got minus 150. So this is your balanced. This is balanced. Then what is the moment? This balancing moment that you have to take carryover. The half of the moment you have to take to the other end. So minus 43.34 divided by 2. So here this is minus 21.67. Other end of the member. Then after taking the carryover, then you have to take the total moment for distribution. This is 150, and this side minus 150, and here this side you take the sum of these two moment, 106.66 minus 21.67. This is 84.99, and this side is your 0. This is 0, and here this is 0. This is minus 53.33, and this is plus 53.33. And this moment you have to take. Already this is your balanced. Already at the overhanging end, the moment is balanced. Then you do the balancing and the carryover of other joints. Then you take the carryover and balancing and carryover of joint 2, 3, and 4. And this joint 1 is your already here balanced. So what is the moment here? What is the moment at the joint 2? So this side you know 84.99, and this side you know 0. So what is the unbalanced moment at joint 2? 84.99, and this moment you have to multiply with this 1 by 3, and you have to put here in opposite sign, because this is positive, so you have to put in negative sign, minus 28.33. Similarly, what is the unbalanced moment? 84.99. This moment you have to multiply with 2 by 3, and you have to put here in opposite sign, minus 56.66. So what is this total moment? This should be equal with this one, because this is you got in positive, the unbalanced moment, and here you have to take this is your negative. The sum of the moment should be equal to this one. Similarly, what is the net moment at the joint 3? Here the net moment is your this side minus 53.33, and this side the moment is 0. So what is the net unbalanced moment here? Minus 53.33, and this moment you have to multiply with 1 by 2, and you have to put here in opposite side, and minus 53.33 into 1 by 2, and you have to put here in opposite side. So this total is your plus 53.33. This should come plus 53.33. Similarly, what is the moment here at joint 4? This is 53.33 into 0, and here you have to write 0. So this is the balance of the joint 2, 3, and 4. Then you have to go for the carryover, because here you see, so this moment will not carry over to this end, because this is already balanced. At the overhanging end, this is already balanced, and you know the moment at the joint 1 is equal to 150 this side, and you got this side is minus 150. This is already balanced, so there is no need to take the carryover to this end. Only the carryover takes place. This moment will carry over to this side. This moment will carry over to this side. Half of this moment will carry over to this side, and half of this moment will carry over to this side. And here also half of this moment will carry over to this side, and half of this moment will carry over to this side. This is the carryover moment. 26.67 by 2, 13.34, minus 56.66 by 2, minus 28.33. This is 0. So here this is 0. 26.66, this side 13.33. So after carryover, again you have to go for the balancing the moment. So here are joint 2. So what is the moment here? 13.34. What is the moment here? 13.34. At joint 2, what is the net moment? 13.34 into 1 by 3, and you have to put in opposite sign. 13.34 into 2 by 3, and you have to put in opposite sign. Similarly here, what is the net moment? Minus 28.33, this side 0. So this is the net moment, and you have to multiply with 1 by 2, and you have to put in opposite sign. And multiply with 1 by 2, put in opposite sign. And here this is 0 into 0, this is 0. This is 13.33 into 0. This is 13.33 into 0. So you have to put here 0. So this is the balance. Then again you have to go for the carryover of the moment. So this moment will carry over to this side half, and this moment will carry over to this side half. This is carry over to this side half. This is moment is carry over to this side half. This is carry over. 7.09 minus 4.45, 0, 7.08. Then again you have to go for the balance. So what is the moment, net moment here? So this moment you have to multiply with this one, 1 by 3, and you have to put here. And this moment you will multiply with 2 by 3, and you have to put here. Similarly, what is the net moment here at joint 3? Minus 4.45. Then you have to multiply with this half, this net moment, and you have to put here in opposite sign. And this is you have to multiply with half, and you have to put here opposite sign. And here this is 7.08, and the distribution factor is 0, and you have to put here 0. So this is the carryover and balancing the moment. Again, you have to go for the carryover. Half of this moment will carry over to this side, half of this moment will carry over to this side, half of this moment will carry over to this side, half of this moment will carry over to this side. So this is the carryover. 1.12 minus 2.37, 0, 1.11. Then again you go for the balancing the moment. 1.12 into 1 by 3 minus 0.37, 1.12 into 2 by 3 minus 0.75. Then here net moment is your minus 2.37 into 1 by 2, and you have to balance by positive sign. Negative means you have to go balance by opposite, plus 1.19. This is plus 1.18, and here 0. Again you have to go for the balancing the moment, 0.6. This is the balancing, this is the carryover. Again you go for the carryover of the moment. This is, then again you go for the balancing the moment, then again you go for the carryover, then again you go for the balance. Here you got very negligible value. Here you see at the end you got very negligible value, so here no need to take another cycle. Here you got the balancing minus 0.03, minus 0.07, 0.10, and 0.100. So then you take the sum of all the moments. Here this is 150 minus 150 already balanced right here. Then you take the sum of the moment from this value, 84.99, M21, 84.99 minus 28.33 minus 4.45 minus 2.36 minus 0.37 minus 0.20 minus 0.03. So this is 49.25. Similarly, find out M23. This is minus 56.66. 13.34 minus 8.89, 7.09 minus 4.73, 1.12 minus 0.75, 0.60 minus 0.40, 0.10 minus 0.07 minus 49.25. Similarly, for 3-2, this is the moment you have to take sum, 26.67 minus 28.33, 14.17 minus 4.45, 2.23 minus 2.37, 1.19 minus 0.38, 0.19 minus 0.20, 0.10. This is the moment. Similarly, M34, this is the moment, and M43, this is the moment. So these are the final moment. After getting the final moment, then you have to give the direction of the moment, and you have to draw the bending moment diagram. You know that how to draw this bending moment diagram and shear force diagram that you can draw. This is the final moment, M15 150 kilonewton meter, M12 minus 150 kilonewton meter, M21 plus 49.25 kilonewton meter, M23 minus 49.25 kilonewton meter, M32 8.82 kilonewton meter, M34 minus 8.82 kilonewton meter, M43 75.54 kilonewton meter. This is the final moment. Then you can plot the bending moment diagram. Now clear? So how to do the analysis of three-span continuous beam when one end is fixed and the other end is overhanging. Now all are clear? Now I will stop here.